Hi dears, welcome to today's session. In the last class, we have started the chapter Paths of Heat Flow. In it, we discussed about conduction. Conduction is the mode of transferring of heat in solid substance. Did you remember that? Then, what is conduction? Yes, conduction. When one end of an object is heated, the molecules at that end receive heat and transfer the heat to the neighboring molecules. This method of transmission of heat is called conduction. Metals are good conductors of heat. Do all the metals conduct heat at the same rate? Let's see. Take three metal rods made of copper, iron and aluminium of the same length and thickness and arrange them on wooden blocks as shown here. Instead of rods, you can use sheets of copper, iron and aluminium of the same size. Fix a pin using wax at one end of each metal rod. Heat with a spirit lamp the point where the rods meet in such a way that they receive equal quantity of heat. What do you observe? Yes, you can observe that the nails struck to the metal strips begin to drop one by one. All the pins didn't fall down at the same time. Pin from the copper plate falls first, then pin falls in the order aluminium plate and then iron plate. Heat is conducted to the three metal plates, but the conduction is not at the same rate. Copper conducts heat faster than aluminium. Iron comes only behind them. Among iron, copper, zinc and aluminium, heat conductivity in the decreasing order: copper, aluminium, zinc and iron. Now you have understood that heat transfer in solids. Let's see how heat is transferred in liquids. Fill 3/4 of a round bottom flask with water. Take a few crystals of potassium permanganate in an aluminium foil and pack it firmly. Make a hole in it with a pin and keep it immersed in water. Heat the flask using a spirit lamp. Observe the changes inside the flask. On heating, potassium permanganate solution moves upwards and the cold water moves down to that place. That is, the heated particles carry heat with them, and when in contact with the colder particles, they absorb heat from the heated particles. Colored particles are used to see the movements. After some time, the color spreads everywhere. Is it clear that the heat transfer takes place in water is due to the movement of the heated water molecules? Conduction is the method by which heat is transferred through the movement of the molecules in gases and liquids. How does heat transfer takes place in gases? Let's see. Open the shuttlecock container on both ends. Make a small pencil thick hole at the height of 8 cm on one side. Fix a lighted candle on a table and place the container in such a way that the candle is inside the container. The hole in the container should be towards the bottom. Bring a glowing incense stick near the hole on the side. Observe the direction of flow of the smoke. In which direction does the smoke from incense stick flow? Yes, The smoke from the incense sticks enters into the container through small hole and comes out through the opening above the candle flame. Place your palm at the top of the container. You can feel hotness on your hand. The reason is warm air rises vertically. It is through convection that heat transmits above the lighted candle. When the air inside the container gets heated, it moves upwards. Cool air flows to that part through the hole. Along with this, smoke from the incense sticks also enters. As in the case of liquid, here too heat is transferred from one place to another through the actual movement of particles. So we can conclude that it is mainly by convection that heat transfer takes place in liquids and gases. Students, let's conclude today's session. Today we have studied another mode of transmission of heat, that is convection. See you in the next class. Thank you.